So we started talking about transition metals, and at the end of last time, we'd given an introduction to all the sort of nomenclature and things you need to know, and we had just gotten up to d orbitals. And when you're talking about transition metals, you're talking about d orbitals. So we're going to start with a little review of d orbitals. Some of you have seen this before, maybe some of you have not, but here is the what you're going to need to know about the d orbitals. You need to know the names of all the d orbitals. You should be able to draw the shapes of the d orbitals. And so the bar is not too high for this. You see the drawings that are in your handouts. You should be able to do about that well. It doesn't have to be super fancy, but you should be able to draw their shapes. And you should also be able to recognize which d orbital it is. If you have a picture of different d orbitals, you should be able to name that d orbital. So let's just review what the d orbitals look like. And in this class, we're always going to have the same reference frame. So we're always going to have the z-axis up and down. The y-axis is horizontal, and the z-axis is coming out of the board and going into the board. So we'll always use that same description. It'll often be given, but if it's not, you can assume that's what we're talking about. So the first d orbital we'll consider is dz squared. It has its maximum amplitude along the z-axis, and it also has a little donut in the xy plane. So dx squared minus y squared has its maximum amplitude along the x and the y axes, so directly on axis for this particular d orbital. The next sets of d orbitals have their maximum amplitudes off axis, so they don't correspond directly to the axes that I just mentioned. They're in fact 45 degrees off axis. So we have the dyz shown here, dxz shown here, so maximum amplitude 45 degrees off, z and y axes, or z and x axes, and then these pictures are a little bit complicated to see, dxy, so it's 45 degrees off of the x and the y. And so here I tried to draw them all in the same orientation of axes, which is a little bit difficult. So now let's look at them in terms of where they're drawn so you can kind of see them a little bit better. And so why don't we try to learn to recognize all of these? So what is this one called? dz squared. What is this one? So its maximum amplitude is along x and y. dx squared minus y squared. I think this picture might be a little, you might have a somewhat of version later on, but this is just good practice for you in recognizing them. So here we have one 45 degrees off axis. Which one is this? Yep. And this one over here? Yep. So y, z. And this last one here? Yep. X. We have the xc. So it's going up and down for the z-axis. So a little